Awesome. Well, thanks folks for coming. My talk is on cloud infrastructure management and security with open source technology. So in this presentation, I'm going to discuss some of the open source software and technology that can be used for helping teams organize and manage their secure public cloud infrastructure. Some of this tooling we use either currently or looking to implement within the Riot space. I will let you know that I am going to be speaking from a public cloud perspective from AWS, since that's what we use, although ideally process and tooling could be used within the Azure, GCP, or whatever your public cloud or even hybrid/private cloud offering of choice could be. The ultimate hope is you are able to take some of this knowledge and information away, and hopefully it will give you like a +1 to your skills and knowledge in cloud infrastructure management and security going forward. So next slide. Again, introduction, we're going to talk about our public cloud environment, how we manage our cloud infrastructure, how we secure our cloud infrastructure, and then just some lessons learned and closing thoughts through things. So I have to warn you, this presentation may have a maximum overload of GIFs, memes, and overall shit posting material in it. You have been warned. And one more thing, I don't regret anything. So a little bit about me. I have been doing systems and software engineering now for about 20 years. Prior to coming to Riot in 2021, I was working with Red Hat. I was doing cloud infrastructure and security, primarily OpenShift, but other Red Hat assets such as Red Hat Virtualization, Ansible, Ansible Tower, Satellite, just regular RHEL as a whole. Prior to going back out into private sector in 2017, I've spent most of my majority career either as a contractor or as a government civilian in the Department of Defense, specifically with what was Space and Naval Warfare System Command, which is now Naval Warfare System Command. Some of you may be familiar with that. Let's talk about Riot Games. So Riot was founded in 2006 by Brandon Beck and Mark Merrill. In 2019, Riot released League of Legends. League is going into its 12th year now, and it is one of the largest esports there is in the entire world. I think like last year during the 2021 World Finals, we had like 73 million concurrent viewers for the finals. We also publish other games as well too, besides League. We have Teamfight Tactics, we have Legends of Runeterra, we have Wild Rift, we have our tactical first-person shooter in Valorant. We also have other games that are coming to console, or our own console right now, such as the Switch, such as like Hextech Mayhem and the Ruin King. Riot just doesn't do games though. We also released Arcane last year on Netflix to critical acclaim. I think we swept like 9 or 10 Annie Awards recently for Arcane. We have also done a virtual K-pop group in KDA as well too. So Riot's not just games anymore. We're doing, a lot of stuff within the entertainment field as well. So at Riot, we aspire to be the most player-focused game company in the world. And what that means for us is that we want to go where players are at. And we want to provide the best possible game experience for players no matter where they're at. And for us to be able to do that, that means that we need to go where they're at, whether they're in North America, Europe, Asia, the Middle East, Latin America, Africa, and we need to be able to provide them with a quality experience, which usually means that we need to have the flexibility to expand our game infrastructure out at any time to meet the player demands. And how we do this is we leverage AWS. So this map is a little dated. It's probably from about 2 years ago, I want to say. But this kind of gives you an idea about AWS's global data center footprint. Not just in North America, but also in Europe, also in Asia, also in parts of Africa and the Middle East. And it's not just the data centers as well too. They also have outposts as well too that you can use to tie back into nearby data centers. For us being in a public cloud and an enterprise cloud provider like AWS, this provides us with the ability to scale up and scale out our cloud infrastructure to meet player demands. Which means that our SLAs that we have for Valorant, for example, which is 128 tick frames and 75 or less ping for players. For 70% of the population, like we're able to achieve those goals through creating ephemeral infrastructure. And then, once we're done with it, we can retire that ephemeral infrastructure, which helps us out a lot because we're not owning the data center. We're not owning the physical management. We're not owning like the bare metals. We're using infrastructure as a service going forward. So let's talk about what that kind of means. So at Riot, because we have many different integrated product teams across the enterprise, we have various numbers of accounts. And we use AWS organizations as a part of Riot to be able to group and organize our accounts. Right now, we're over 200 accounts with Riot, and we are growing steadily across. Some accounts we want to give, a breadth of access to AWS services and APIs. Some accounts we want to be a little bit more controlling on that, and organizations kind of helps us in that because we can group these accounts in certain OUs. We can control access to services and APIs through service control policies. We can take logs such as VPC flow logs and CloudTrail and pipe it all into one consolidated account for auditing and security purposes. We can also separate things out within AWS across a product lifecycle. So we're looking at sandbox accounts, development accounts, system integration and testing accounts, pre-production, production. Organizations are very, very flexible, very, very powerful, allows us a great level of control that we can use within AWS. So for us, that generally means that we AWS all the things, and player platform gets an account, and enterprise services get an account, and lead gets an account, and data services gets an account, and everybody gets accounts. And it gets very, very hard over time to manage, not just like the number of organizations and accounts that we have, but just the continued growth that we have as well too. We want to AWS all the things. We want to be able to make leverage of this ephemeral infrastructure that AWS has. And, this kind of gives like small sampling of the things that we use. We use EC2, we use Lambda, we use EKS, Transit Gateway, API Gateway, key management services, guard duties. Like this right here is just a small sampling of the things that we use within AWS resources, as far as AWS resources go. Now, the problem with this is everything that you use within AWS does have associated accounts, a cost to it. And, I don't know about you folks, but like having to explain to people your cloud spend to your finance and budget folks is not necessarily always the best conversations that you need to have. And even in some of the managed services, there are costs associated just using these managed services. Even though they help you control your costs, there are still costs associated with it. So, we're trying to manage all this stuff, and I'm going to assume naively, maybe I'm wrong, but I would think I'm right, that we're not the only ones that are having these problems. if we're not the only ones, then maybe there are other people out there who have had the same kind of problems that we've had. Maybe they've created some tooling that, that's helped them solve their problems. And maybe they've even published this tooling with like the source code out there showing like, how they went about and solved these problems. And when you kind of think about it in that way, that sounds like open source software. So depending on who you talk to some people, they're going to bring up questions. It's like, isn't open source software difficult to use? Isn't it less secure than proprietary software? Doesn't it really cost us more to use open source software? Well, people look at it from security, and people look at it from, a difficulty of use and cost as well too. However, one of the things that I argue that makes open source like a true game changer is something that Kelsey Hightower said. Open source is about collaborating, not competing. And the power behind open source is that we're all engineers who have the same problem, just in different situations, different kind of settings. And open source allows us to collaborate and work out within a public space how to solve same issues and same problems that, not just us at Riot are experiencing, but, from like the small 5-man shop all the way up to large enterprises. It gives us this ability to, look at the problem spaces from, that we're having from like different perspectives, and, see how people have come about like solving the same problems that we're having, and maybe even being able to leverage those solutions within our environment. And when you kind of think about it that way, like, open source can be a tremendous force multiplier in a cloud native and a cloud centric world. Business demands are always changing. Requirements are always changing. Resources are pretty much limited for the most part. So when you can kind of make the argument that there's a low cost entry with open source, and it helps us, effectively and efficiently solve problems to, your managers and, your senior engineers and, your business owners, then you start getting into the parts of things, or the part where people just want to like use all the open source things, and they get really excited about it. And it's like, okay, great, awesome. Where do we start? That's not an easy thing to, usually kind of lead people into, because, I mean, there's a lot of open source software and projects out there, a lot. And when you get into the cloud native and CNCF environments, it really gets difficult to kind of like figure out where to start. And the landscape can be very disorienting, very much like Alice going down the rabbit hole. So let's try and establish an approach to how we adopt open source within our environment. And this is how we kind of do it, at Riot. When we're looking at open source tools for our cloud deployments, we prefer to leverage well-known, well-adopted open source projects for repeatedly deploying the various architectures across all our units. Things that we look for typically has, wide scale adoption in industry. There's large community support with the tooling. With the large community support comes a large knowledge base, and that knowledge base has multiple points of entries into it, whether we're talking tech Twitter, whether we're talking about videos on YouTube for showing how to use these things, whether we're talking about like Stack Exchange, it having like its own like listing within Stack Exchange, whether it has like wikis, etc. And typically these large, tooling sets will have some sort of like downstream enterprise offering. So what I mean by that is, for example, Foreman as a upstream project to Red Hat Satellite, or Terraform as, the upstream project down to like Terraform Cloud, which is the enterprise offering from HashiCorp. And typically how we want to fit this in is, within a DevSecOps model, which I would assume most people are familiar with, but if not, basically it's, we're going to do planning, code, build, testing, release, deploy, operate, monitoring, throughout that entire cycle, while also injecting security in the process as well too, which means we're going to do code scans, we're going to do scans of builds, we're going to do testing to make sure that it's secure and that, when we deploy, it's secure, deployed out in our environment and it operates securely, and we monitor all the things and then we iterate from there. So let's start talking about how we do things at Riot. One of the cases I'm going to talk about here is building secure base AWS AMIs. I am responsible for building the AMIs for Riot. We offer both Linux and Windows. For Linux, it can be the various distros, Amazon Linux, Fedora, CentOS, Ubuntu. The model that we use for this is we have a Packer file and we have Ansible tasks and roles that come along with this. I, as a person who's mostly responsible for this, I generate new Packer build files every month. Generally don't update the Ansible roles unless I need to split them out for like new things I could potentially support. Git is my source of truth. So everything gets, when I'm developing for a monthly release, everything goes into a Git branch. We scan the Git branch for security issues. If there's any issues with like failures on the test, then it means I need to go back and reiterate against my Packer build manifests. If the tests pass, then we go into Jenkins, which is our CI platform that we use. We go through a build. If the build passes, then we go on and we do a test. For testing, we use Chef Inspect. It goes through, it fires up the AMI that just built. It runs through a series of tests to make sure that there are security settings in place. If everything checks out and looks good, then we have a CLI tool that's Go-based. It also uses the AWS API, which we have to have the CLI, which is why Python's there. And it copies this newly created AMI into every single account we have in every single region in AWS. If this fails at any one moment, then Jenkins alerts. We go ahead, get a notification, restart the process. Fairly simple, but look at the toolings that we use. Ansible is a very common tooling used for configuration of systems. Packer helps you create, secure images. Golang, Jenkins is, a very popular CI/CD tool of choice, although I'm trying to get us away from Jenkins as fast as possible. Chef Inspect for doing our testing, and then the Golang tooling in Python. Going to next case, let's talk about Terraform security scanning and auditing. So we use a lot of Terraform for our infrastructure. We don't use the enterprise offering, we just use the community offering right now, although we're looking to possibly expand down into the enterprise offering at some point. So our Terraform that we use, I'm just going to use EKS as an example. I have an EKS sandbox cluster that I use for my own personal testing of things EKS related. I use an offering from AWS Samples, this EKS Terraform Accelerator Git repo as my basis. So I have the Terraform, I will make modifications to the Terraform, then I will use something like tfscan or tfsec from Aqua to check against whether I have particular issues with my Terraform that I'm trying to pass off. If tfsec passes, then it gets checked into Git. If I wanted to merge, from a working branch into a mainline branch, Then I create a PR against that, and I've integrated a tool called Atlantis, which effectively what Atlantis does, it goes through and it runs through a Terraform plan to show me where things will change, things get created, things could potentially get destroyed. Atlantis gives full visibility into like the auditing of your infrastructure. So a reviewer who ultimately has the final say before something merges into a mainline branch can see these changes as well too. Atlantis can run on Fargate, regular EC2, EKS, vanilla Kubernetes. If it gets, if the plan goes through, reviewer looks at it, merges it within main, then process kicks off via Jenkins to deploy into AWS. Again, one of the things that I've mentioned is I'm trying to get us away from AWS and started playing around with Argo to help us implement that potentially going forward in the future. Let's take a look at tfsec real quick. So it's a command line tool, pretty simple, and I'm within my EKS clusterized environment. So again, fairly simple as far as the tool says, as far as like the options go. Demonstrating in here what my Terraform repository looks like. I'm going to do a tree on it, and it shows that I've got, here's my structure out here. So I'm not just using just a main Terraform. I'm also deploying some other stuff that comes along with it via Helm as well. Going to go ahead and take a look and see what happens. It's a relatively quick process for this. When it comes back, it gives me my results in a fairly detailed way. It categorizes everything from just an informational all the way to high critical. And the nice thing about it is it gives you that visual feedback. You can use this and like actually plug this into your repo as well too, such as like if you hit like criticals or highs, for example, you can block code from actually going within the working branch, which is nice. Now the question comes down, it's like, okay, I have all this information, so how do I remediate this? Well, the nice thing is if you go back real quick and you look at some of the output that's underneath these, it actually provides link within the tfsec documentation on, for example, AWS instance about the metadata service. It tells you like where the severity ranks, it gives you an explanation on it, and it actually gives you an example of an insecure example and the secure examples that you can use to implement within your Terraform code. So you're actually getting that feedback and the information you need to create more secure, robust, and manageable infrastructure as code. That's pretty powerful knowledge. And to me, knowing is half the battle in this space when it comes down to implementing infrastructure that is, well, can be managed, but is also, fairly secure when you deploy. Let's talk about identity and access management while we're talking about like AWS accounts and deploying things. IAM is really, really, really hard, just even for one account. Now, imagine trying to do this at our scale where we have hundreds of accounts, different OUs, having to worry about things like access keys and secret keys and how long they live and have they been rotated and things like that. It's almost like kind of like the Hulk jumping in to face Surtur. It's a Herculean task. It's pretty good luck is all I'm going to say is if you're going to take that route as best as possible, trying to manage like access keys and secret keys and rotations by yourself. So let's look at it from a different perspective. This came from 2B Engineering. This is something that we leverage in a similar manner within our environment. So we have an Active Directory federated structure with users and groups. We use multi-factor authentication, and we have a SAML provider that we use to be able to log into our AWS accounts. And the thing that I want to draw attention to in this model is STS. So we're talking about AWS's security token service. And what that does is allow you to get short-lived credentials for access keys and secret keys. And it can be anywhere between minutes all the way up to, say, 8 hours, 10 hours, 12 hours. But the nice thing is once the credentials expire, nobody can, use those credentials to be able to invoke the AWS API to create services or do anything within the account. The other thing as well too that's nice is you don't have to worry about the management of this, because once it expires, it expires. So to be able to use this, we actually created an open source project called Key Conjurer. And in Key Conjurer, we use AWS's security token service that can generate those temporary just-in-time credentials. We tie it into our Active Directory users. We tie it into the MFA, and we tie it in our SAML SSO provider. So there's a couple parts to it. There's a CLI tool that developers and users can use to get those credentials. There's also the web front end that can be used as well too, that you can tie in a part of this. It's built on Node and NPM. The repo is located at github.com/riotgames/key.conjurer, key-conjurer. And we welcome contributions from the open source community as far as like helping us to, check things as far as like, errors or bugs that we may have, missed in part of our development, but also as a tool for other people who want to be able to leverage the same kind of model within their workflows. Going on, let's talk about container vulnerability scanning and software bill of materials. So as part of the infrastructures, we use EKS as our container orchestrator, and containers are awesome. Containers are scary as well too, because you pull something from public GitHub, for example. Let's just use Golang 116 because that's a particular piece of software. That's a particular container that you need to use because your software service is using Go 116. So like when you pull it from GitHub, like how secure do you really know that container is? And what do you know about like the other packages that are being packed along with it as well too? Because it kind of helps to know what your surface attack looks like from it and where you could potentially have issues. And two open source tools that are provided from Anchor, Gripe and Sift, can help you kind of get that visibility. So Gripe is a vulnerability scanner for container images. The database pulls from AWS's ALSA, Red Hat's RHSA, CVE, the NVD, Linux security, Ubuntu's Linux security bulletin, etc. It automatically manages the database for the user. It will go ahead, it will do a container scan, and then from everything that it takes in, it will give you a listing of what you've got, what the vulnerability is categorized in, whether it's a critical, high, medium, etc. But it will also tell you whether it's going to be fixed or not. And that could be really helpful for folks. When they go and they pull, images down, whether, if they see that it's not going to be fixed, well, then it starts kind of helping the planning about like, hey, what do we need to do to be able to get onto like a new container baseline that takes care of our issues from a security perspective. Sift is a tool that can generate the software bill of materials for a container image. The nice thing about this is that you can use it within a tool like Cosign to be able to attach attestations to images. So we offer what we call golden base images to our consumers. We can use Sift along with Cosign to generate the attestation so that our image consumers within Riot know that what we're using is coming from a trusted source, which would be information security. So let's take a look at this in action. So I'm going to go ahead and I'm going to start pulling down Golang 116 because that's what I was talking about earlier. it will go ahead and it will update the vulnerability database. It will start the process of pulling down the image. This is a rather large image. I think like Golang 116 was almost like a gig in size, which is, I mean, that's a pretty big image size. And that's a lot of packages to be packed along within, just a regular, what we would call like base container for use. Goes through, it starts the process of loading the image and starts doing its scans that come along with it. I thought the video stopped there for a second. Okay, so it's continuously going through, it's doing its scan. Boom. So from here, I can see everything that's within this particular package, and I can see other CVEs that are listed against it, along with like what their ranking is. Then I can go ahead and generate the software bill of materials as well too. It's thinking, it's thinking, it's thinking, it's thinking. Boom. And there you go. It gives you a list of the packages that are in. It also gives you a list of the versions as well too. So again, let's think about where something like the software bill of materials could be useful. So the poll kit, policy kit vulnerability a couple months ago, we would get questions from our internal users about whether their containers were bad or not. And SIFT was one of the first things I would tell them to use to scan against their internal containers so that it could see if it had policy kit or not. And if it did have policy kit, probably need to go ahead and replace/rebuild your containers to make sure that you are taking care of policy kit from a vulnerability perspective. For me, these two tools right here, it helps you win at being secure in a cloud native world through power of open source software. While we're talking about Kates and while we're talking about containers, let's talk about conformance testing. So conformance testing ensures that your cluster, your offering meets a minimal set of features and services guaranteed. It ensures that you're meeting best practices. It's predictable, meaning that everything's well documented. Unexpected bugs are rare. Interoperability, though, is the big thing. So we use EKS. Let's say we wanted to move to OpenShift from Red Hat, for example, because EKS is certified through conformance testing and OpenShift is certified through conformance testing. That means that we should be able to take our workloads and port them between EKS and OpenShift and have minimal hiccups due to the offerings being standardized. This can also be done on just your homegrown open source offering. So let's say that you wanted to take upstream Kubernetes and create your own distribution offering. Well, you can use something from Sonobuoy, which comes from the Tanzu group, and which is also the standard used to certify Kubernetes clusters to ensure that they meet conformance testing, that they meet best practices, that they meet predictability, that they meet interoperability. We also use this with our EKS offerings because different product groups will take EKS and change things around to meet their business case and their business, their potential use cases, their potential requirements. They still need to be able to conform because we need to have some level of predictability and interoperability as things migrate from, say, one particular version of Kates to another particular version of Kates. And we need to be able to use things like Sonobuoy in the conformance testing to ensure that they do so. For cluster security tooling, you can use tools like Kubebench. So in particular instances, we need to meet CIS benchmarks, or EKS benchmarks based from CIS, and KubeBench can help you with that by running checks against your cluster to see where you meet the CIS benchmarks, where you don't meet the CIS benchmarks. Kube Hunter can be used for a security scanner of your cluster to go through, look for security weaknesses, and can actually map right back into the new MITRE attack matrix for K8s. Kube Audit can be used to make sure that you're implementing the various security functions. So like, read-only root file systems, don't run as capsys admin, or privileged containers within your environment. And once you have everything kind of within an idea of how you want it to be deployed, then you can use something like Kubernetes, which is a penetration testing tool for K8s, where it automates all known techniques and attacks that you can go through, and you can execute against your cluster and figure out where you are good to go and where you've got some problems and need to take care of that. Once you kind of figure all that out, then you have some tools like Falco, which you can put on your nodes that can enforce security runtimes and rules. And you can use open policy agents as well too to enforce policy within your cluster. So to ensure that you can't port, open policy agent can be used to disallow port forwarding or particular users for being able to deploy things within clusters. And then cloud security training and knowledge, because let's be honest, things change at a rapid pace. And especially within cloud environments, what you do within a private data center is not necessarily what you would do within an AWS environment. So things that we use for our purple teaming and with general infosec knowledge, offensive Terraform, Cloud Goat, ImpactU can be used to help generate some inherently vulnerable by design infrastructure within AWS, so that you as a information security professional or as a person who wants to know more about information security can go through, stand up these pieces of infrastructure, and then start learning all about the various ways how to secure the infrastructure. KubeGoat does the same thing for Kubernetes clusters from an open source perspective. Stratus Red Team is a new offering that's come from Datadog. KCTF, which is Google's Kubernetes Capture the Flags service, stands up a cluster that you can go through and execute against various capture the flag techniques. These are just a sampling of some of the tools that we internally use within Riot to be able to help, level up our cloud security kung fu, and gives us knowledge on how to better secure our public infrastructure that we have from an AWS perspective through continuous learning and exercises. And the nice thing about all these projects, for the most part, is they are, they're open source, they're well maintained, they're updated on the regular, because AWS changes, the API changes, the services change, and as things change, you need to be able to continuously reevaluate where your skills are at, your knowledge base, continuously improve what's happening within the cloud provider service. And again, having these open source tools, at your disposal really, really helps in the long run of things. So lessons learned in closing thoughts from my perspective. Lessons learned, open source is very powerful. There is a plethora of tools out there that individuals can use, that companies can use, that teams can use. But when it comes down to open source, again, what I'll reiterate is, use things that typically have wide adoption and support, things that have like a large user base, that has a large body of knowledge and ways that you can get into the body of knowledge. Again, whether it's through tech Twitter, YouTube, subreddits, Stack Exchange, whatever, that provides you access. And, for your larger enterprise, maybe something that has like a downstream offering, an enterprise offering, because you're going to want, enterprise businesses are going to want stability and reliability. The other thing as well too, I will say, from using open source tools, while it's great and awesome and can be a force multiplier, keep up with what the community is doing, because software changes, projects change, APIs change, they get, you know, either updated, deprecated, whatever. And from a supportability perspective, you need to be where the community is at, because if you're not there, you're not going to get any help. Free as in beer is awesome, but don't expect the community to sit there and continuously support you if you're, you know, on an outdated or an end of life version. They're just not going to do it. And then you're kind of on your own from that perspective. So, you know, keep up to date with what's happening. You know, try to stay as lockstep with the community as much as possible. And as far as, you know, the community goes, participate. What I would argue is you don't have to contribute code. You can do testing on some of this stuff. Help with writing documentation. If it's, you know, if certain developers offer, like, you know, a PayPal or something, donate $50 to them, because, you know, these people who are doing these things, you know, a lot of times they're doing it out of love, and sometimes they're doing it without any like company backup or industry backup. And, you know, helping to fund them to be able to continue to do these things can be very, very beneficial, especially when you're talking about tools people use like curl, wget, OpenSSH, and OpenSSL. You know, developers need to be able to pay, you know, need pay in order to be able to like do things outside of like writing code all the time. So, you know, find ways to be supportive within the community. And I guess with that, I'll just open it up to the floor for like anybody who has any questions or, you know, comments, etc., whatever.
Thanks, Hugh. I know someone had raised their hand earlier, but I don't see it now. So we've got about 2.5 minutes. So if anybody has any questions they'd like to ask, now is your chance. And is there, Hugh, is there anything that you wished you had included in your talk that maybe in these last few minutes you'd like to say?
Oh God, OS query. Like OS query is awesome. Highly recommend OS query, especially when you tie it in something like Fleet VM. Like you want to talk about like complete visibility of asset management. OS query is awesome. Cube query is awesome. Let's see, or cloud custodian from like a general like policy perspective. I could go in like whole talks about Falco and open policy in general. Just like going back to that slide with the CNCF and all the projects that are out there, like it's daunting trying to wrap your arms around everything that's out there open source, because it's just almost impossible. And like I was saying before, it's growing. New projects are coming online every single day, every single hour, that could end up becoming something big as an Ansible, that could end up becoming something big as a Terraform. And, you know, kind of going back to something I was saying earlier before, it's like never stop learning, never stop, you know, try and keep up to date with what the community is doing. Like really, in all honesty, try to keep up with what the community is doing. I know it's daunting, but do your best, because you don't want to be left in a situation where the tooling and the solutions that you're using today become, you know, the old and busted, and everybody's moved on to the new hotness, so to speak.
Oh, just a statement there from Kevin Ford in chat for you. And since our next speaker isn't here yet, we can keep chatting if you'd like.
You know, really, in all honesty, what I would say is that, you know, from our perspective, I mean, we're we're always looking for knowledgeable AWS folks and security folks as well too. So kind of goes back again into the, don't stop learning, like I would say one way to make yourself attractive to companies in general is just get involved. Get involved, speak about a topic somewhere, help out with a project somewhere. Again, whether it's, documenting or, maybe even creating knowledge material like videos, tutorials and things like that, that kind of helps get yourself exposure. I know playing around in AWS can be a very expensive kind of proposition, but again, if you have the ability to be able to use the free tier, leverage it to as much as you can. AWS also provides a wealth of tech talks, through YouTube, through AWS online tech talks and AWS events, and there are code repos. AWS Samples is one of the organizations that offers just tremendous amounts of source code out there. Take advantage of some of that stuff. From other knowledge perspectives as well too, I would argue, O'Reilly, the Safari learning online, Pluralsight, Cloud Guru, these things, like, don't stop learning. That's how you make yourself attractive to companies like Riot.
Hugh, thank you so much again for your talk and for chatting with me at the beginning of your session and answering some questions and giving just words of wisdom for people getting involved in open source in general. And also thank you for your talk. It was very insightful, and thank you for being part of Open Source 101 this year. I look forward to hopefully our paths crossing again at some other events, both virtually and maybe in person throughout the rest of the year and going forward. So thank you again.
Cool. Thanks, everybody.